Okay, good evening all. Uh, from last lecture we- okay, from last lecture we have started our last chapter, that is destructive testing and non-destructive testing. And in the previous lecture we have learned the what is the difference between the destructive testing and the non-destructive testing method. For which purpose we are doing the destructive testing and for which purpose we are using the non-destructive testing methods. And from that we have started the non-destructive testing method, and we have completed. Okay, I will just take a review. Okay, we have started completed this part in the yesterday's lecture. What is the meaning of non-destructive testing method, then why it is conducted, means its purpose, or what is the aim of conducting the non-destructive testing. Then various types are there for that non-destructive testing methods, and from these various types, almost six types are there: visual inspection, magnetic particle inspection, then dye penetrant inspection, ED current inspection, then ultrasonic inspection, and radiography. Out of these six methods, we have completed first three methods in yesterday's lecture only. The first is the visual inspection. That part we have completed. Uh, Visual inspection, which kind of defects can be detected in this visual inspection, and how it will be detected, that we have discussed this, discussed in this part. And then in the magnetic particle inspection, we have started with the what is the concept of magnetic particle inspection, then what are the different types of the magnetization, and which type of cracks can be located with the help of that different types of the magnetic particle inspection. Means for detecting the longitudinal cracks you have to use circular magnetization, and for detecting the transverse cracks you have to use the longitudinal method of magnetization. Then after this, we have discussed this part, liquid penetrant inspection, how this liquid penetrant inspection is conducted, what are the different steps involved in it. We have discussed related to different steps like cleaning, then drying, then application of the penetrant, then removal of that excess penetrant, then application of the developer, and at the end we are doing the observation or interpretation of that what you can say, that the dye or liquid penetrant applied with the help of that developer. Okay, and which kind of defects can be detected by in all these three types that we have seen, which kind of defects may be surface defects, subsurface defects, and for which material you can detect that defects for each method. All this part we have finished in the previous lecture. Now in today's lecture we will discuss about two methods we are going to finish in today's session. The first is the ultrasonic inspection, and after this ultrasonic inspection, okay, this is ultrasonic inspection. After this, we are going to discuss related some principle and its types of the radiography. Okay, now we will start with the ultrasonic inspection. Now here in this ultrasonic inspection, first we have to understand the concept, and after that we are going to discuss the two types of this ultrasonic inspection. Okay. Mm, what is the concept or principle here? Now principle of this ultrasonic inspection will be like this. In this ultrasonic inspection we are going to use the ultrasonic waves. Okay, ultrasonic waves are allowed to pass through the required material, or the material which is required to be tested for any kind of defects or flaws. From that material, that ultrasonic waves are allowed to pass, and we are collecting the pattern. Okay, we are keeping one cathode ray oscilloscope screen at the another end, and we are collecting all the patterns obtained from that different ultrasonic waves, and depending on the patterns obtained on that ultrasonic waves and the time taken. Okay, time taken to pass or to travel the distance from one end to the another end of that test specimen, that time is also measured, and with help of that time measured, and the you can say that pattern obtained on the cathode ray oscilloscope screen. Depending on these two parameters, we can detect the defects. You can say that it may be a internal defect like porosity, cracks, like that. Defects can be easily located, means you can determine its location as well as its dimensions also, means how much will be the length of that crack. Like these parameters you can easily detect with the help of this ultrasonic inspection. Now there will be a question in your mind that what is the difference between ultrasonic waves and a simple sonic wave. Okay, ultrasonic wave. Ultrasonic wave is a type of sonic wave only. Sonic means sound waves are there. Okay, sonic waves will be there. But what is the difference between sonic waves or sound waves and ultrasonic waves? The sonic waves are audible to our ears. Okay, means human can easily uh, it will be audible to a human, any kind of the person which is normal person. It will be audible to that person, and its frequency will be less than 20 kilohertz. Okay, and in case of ultrasonic waves, it is not audible. Okay, it will be not audible to us, or you can say that a normal person, it will be not audible because it is having the higher frequencies. More frequency will be there, more than 20 kilohertz. Okay, this is the difference between the sonic waves and ultrasonic waves. Then we are going to use the ultrasonic waves in this test. Now there are two types of the ultrasonic inspection. Okay, there are two types of the ultrasonic inspection. The first method is pulse echo method, that you can easily see the arrangement for that method or ultrasonic inspection using that pulse echo technique, that the arrangement you can see in this slide. And the second method is transmission method, or this is also termed as through transmission method. Okay, here you can see this is the second type, transmission method, or in some books it is also termed as through transmission method, through transmission method. Okay, now we will discuss one by one. Okay, depending on the nature of the transmission. Okay, how these two types are made in this ultrasonic inspection. Two types are there: pulse echo method and you can say the transmission method, depending on the transmission of that ultrasonic waves. Okay, transmission of the ultrasonic waves and method of collection, its collection or collection of that pattern, depending on that only two types are made. And this is the first type, pulse echo method. Now in this pulse echo method you can see this is the arrangement. Now here this is the coaxial cable to the instrument, and this cable is used to collect. Now the pulse is generated. Okay, pulses are generated, and these are given or transmitted from the test specimen. Okay, this rectangular box you can see, this is our test specimen. I will highlight here, this is the total, the material under test, or our test specimen. Your name is given material under test. Then there is one quartz crystal. Okay, quartz crystal is there. What is the purpose of using this quartz crystal? This is used to transmit this pulse. Okay, pulses which we are collecting from the a pulse generator. Here one pulse generator will be there, and from that pulse generator pulses are created. Okay, pulses, or you can say that ultrasonic waves are created, and that ultrasonic waves are passed through this quartz. Okay, through this quartz, and then that will pass through the material under test. Okay, now these ultrasonic waves will allow to pass from one end of the specimen to the another end. Okay, from one end to the another end. Now here what will happen? There will be two types of the patterns. Okay, two types of the patterns will be obtained. First will be the normal pattern. Okay, this is the normal pattern, means in suppose this is the ultrasonic waves. Okay, from this uh, one end with the help of pulse generator through this quartz crystal, this ultrasonic wave is passing through this material under test, and it will reach to the end of that test specimen, and it will get reflected, and again it is collected here. Okay, so the time required for this will be calculated. For this, first pulse will be calculated, and its pattern will be recorded on the cathode ray oscilloscope screen. Okay, in front of this cathode ray oscilloscope screen will be there. Okay, in front of this, here you have to place one cathode ray oscilloscope screen is connected here, and on that you will get the pattern related to this pulse. Okay, then whenever suppose a defect is present, suppose a crack here, here one crack is suppose here one crack is highlighted. Now whenever a crack is present, suppose the pulse sent from this pulse generator through parts, it will follow this direction, then it will get reflected from the defect, or suppose one crack is there, from that crack only it will get reflected back, and again it will be received at this chords. Okay, for these waves, or the pattern will be recorded. Okay, this will be the nature of the waves. Okay, nature of the waves for the normal side of the material, whenever there is no defect is present, then the pattern is recorded on the CRO. CRO means cathode ray oscilloscope screen. I will term it as a CRO screen. This pattern is recorded. Then same kind of pattern will be recorded for this wave also, where that wave has detected a defect. Then we will get two different spots. Okay, two different patterns. That patterns are termed as the pips. Okay, PIPS. These are termed as the pips. And whenever there is no defect in that material, you will get a bigger pattern. Okay, bigger pattern will be obtained, or bigger pips will be obtained. And when the defect is present at that spot, you will get a pattern or a pip having very small size on the CRO screen, and you are having the record of the time also. Okay, whenever defect is there, it will come back with the shorter time as compared to the normal specimen. Okay, or normal area of that specimen. Then you have to observe this kind of patterns will be there. Okay, this kind of pattern will be obtained on the CRO screen, cathode ray oscilloscope screen. Here I have mentioned that patterns obtained on the oscilloscope screen of the ultrasonic tester. Okay, whenever there is no defect, this is for the first wave. Okay, first wave which I have highlighted here, this is the first wave, and this is the second wave. For this first wave, where there is no defect in that specimen, you will get this kind of spots, or this kind of two spots will be there. Okay, this is for original pulse. Okay, this is for original pulse, and this spot will be generated for the reflected wave. Okay, this is the original ultrasonic wave, for that you will get one spot, and this is the for spot for the reflected wave. Okay, this kind of pattern will be obtained when there is no defect in the test specimen or that particular area. And suppose there is a defect. Okay, if suppose this kind of reflection of wave is occurring due to this defect present in that area, then you will get this kind of spot. Okay, means you will get this second wave. Okay, this type of pattern, or this is termed as this, whichever shape you are able to see here, these are termed as the patterns or pips. Okay, for normal specimen area, you will get this kind of pattern, and whenever there is a defect, you will get a small pattern or small pip is obtained, and the distance is located with the help of calculation of that time, how much time is required. Okay, these two times are calculated, how much time is required for the wave to travel from one end to the another end in the normal condition, and how much time it took to travel from one end to the end at the, I mean, you can say that where the defect is present, that time is compared and its distance is calculated in that test specimen. Okay. In this way, this pulse echo technique is used to detect the internal cracks. It may be internal crack, internal discontinuity, or internal porosity may be there. All these can be detected by doing some time calculations, and with the help of CRO screen, you will able to attain some patterns. By comparing that patterns with the time calculation, you will able to obtain its location, as well as you will able to get its shape also. Okay, so this is the first method of ultrasonic inspection. You can say that it is termed as pulse echo technique. Okay, these two diagrams you have to draw. This is the setup used for conducting pulse echo technique, and these are the results or patterns obtained on the cathode ray oscilloscope screen. Okay, CRO screen, you can term it in short. Okay, so this is the first type. Then the next second type, this is the transmission method or through transmission method. Now, in this case, you can see clearly here. This is your test specimen. This is the center rectangular shape you are able to see. This is your test specimen. This box here, this is one transducer, and this is the another transducer. And output of this end transducer will be given to the CRO screen. Okay, this output will be given to the CRO screen. Here you can write CRO screen. Here you can write CRO screen. This is your test specimen CRO screen, and two types of the transducers are there. Now, what is the function of these two transducers? This first transducer or transducer at one end, it is used to collect the pulses, or in short, you can say that the ultrasonic waves. Okay, this transducer will collect that ultrasonic waves, and that collected ultrasonic waves will be passed through the test specimen. And at the another corner, one transducer will be fixed, and it will collect that, it will receive that ultrasonic waves at the other end, and it will give a signal to the, and that signal will be recorded on the CRO screen. Okay, this will be the arrangement. Now, suppose there is a area where no defect is there. At that time, you will get the different pattern. The pattern obtained will be same nature. Okay, will be of same nature that you have obtained in the pulse echo technique. These kind of patterns will be there. Patterns or pips will be obtained on the CRO screen. Okay, normal sized or large sized pips will be obtained. And whenever any kind of the flaw is there, whenever any kind of the flaw is there, then at that time a different kind of the pattern will be obtained. Okay, or you can say that here, whichever signal is generated by this transducer, it will be stronger when there is no defect, and whenever there is a defect, you will find that the signal will be very weak or distorted signal will be produced from this transducer. And depending on that signals, you will able to find the different kind of the patterns, and you will able to find the that whether the flaw is there. Flaw means nothing but the defect, any kind of defect is present there in that particular component or not. Okay, depending on the pattern obtained on the CRO screen, and by measuring the time required for traveling of that ultrasonic wave from one end to the another end of that specimen, or from one end to the spot of the defect located. Okay, from that defect. Okay, times are calculated, and by comparing that time, you can able to detect the location of that flaw or defect in this ultrasonic testing. Okay, now this ultrasonic testing method can be used for detection of the cracks, then porosities, and this method can be used for metallic components as well as for non-metallic components. Okay, this is the means related to the application application. At the end, you have to mention some applications for each inspection method. At the end, you have to highlight some applications also. Now, this ultrasonic inspection method, this can be used for detecting the cracks, porosities, or any type of the inclusion or discontinuity in metallic as well as in non-metallic components. And specifically, these ultrasonic inspections are used for testing the different types of the structures. In the sense, you can say that different kinds of the bridges are there, metal bridge, and there may be metal bridges, or different kinds of the pipelines are there, bridges or pipelines. Then that bridges or pipelines can be tested with the help of this ultrasonic inspection for any kind of the defects, like cracks, porosity, or any kind of inclusion is there. Okay, so these are the applications of this process. So this is the first method, you can say that. Sorry, today's first method, and fourth method is there from our. I think I have given wrong number here. This is the third. This is the fourth. This is the fourth method. Itself here. This is the fourth. Okay. Whenever there is question in examination related to this ultrasonic inspection, then you have to highlight all these points. Means first you have to start with the which principle you have used there, and after explaining that principle, first you have to explain the principle, and then you have to highlight the different types, and in each type how that principle, or which type of instrument setup is used, that you have to mention there. And you have to explain the procedure and patterns obtained, you have to draw the diagrams, and at the end you have to mention its you have to mention its applications. Okay, at the end of each, for destructive testing as well as non-destructive testing, at the end you have to mention whichever applications are there, that you have to mention there. Okay, please remember this. uh, Diagrams, applications, and principles, all this part is compulsory. Means just try to remember the diagram and how that test is conducted with the help of diagram. All the descriptions you will be able to write by your own. You can write that, means how the procedure is conducted and which kind of testing is done, and for which material it will be done, that you can write here. Very, these are very simple methods. Then after this ultrasonic inspection, we will move towards the fifth type. Okay, and this is, if you are having any question, you can put that in the chat box. Otherwise, I will continue to the next type. If you are having any query, put that in the chat box. Or if all points are clear, I can start the next point. Okay, I'll start the next point. If you are having any query, then put that in the chat box. I will clear it, and then we will move towards the next non-destructive testing method, that is the radiography. Please give some replies. I'm waiting for it. Please put your replies in the chat box. I will wait for 1 minute here. Please provide your reply. Can I start next type? Okay. 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 So this is the next type, that is the radiography. Okay. Now this radiography is used for detecting the internal defects. Okay, in the different kind of the components. Okay, it may be casted component, forged components, or welded component. For that, detecting the any kind of the internal defects present in that component. It may be cracks, porosity, or you can say that blowholes are there, or any cavities there. That all kinds of defects can be detected with the help of this radiography technique. Now, in this radiographic technique, here in this diagram which is visible on your screen, this is the general concept or principle of the radiography. Now, what we are doing here, we are taking one source. Okay, we are taking one source, it may of the x-rays or gamma rays. Okay, or in short you can say that we are taking a source which will give you the radiations, or which will provide you the waves which are having very shorter wavelength. Okay, due to the shorter wavelength they can pass through any type of the component. Okay, due to the shorter wavelength, just you have to use any kind of the source, and from that source you have to get the waves which are having very shorter wavelength. Okay, its wavelength it should be very short. Sometimes suppose you are using the x-rays from x-ray tubes. If you able to get the x-rays, its wavelength is very small, from zero point 0.2 to 5 angstrom. Its wavelength will be in that range. Then suppose if you have used x-rays, sorry, gamma rays, then its wavelength will be shorter than that x-rays, means less than zero point 0.2 angstrom. Okay, it is having very shorter wavelength, and due to that shorter wavelength only, they will be able to penetrate through any kind of the material. They can penetrate any kind of the material, and these wavelength sorry waves will be allowed to pass through the material under test. Okay, this is the test specimen. These wavelength waves will be allowed to pass through that material. Then they will pass through it, or they will penetrate that material due to their shorter wavelength. And during this penetration, what will happen, that material will absorb some amount of the waves, which the waves which are passing, it may be x-rays or gamma rays, that waves will be absorbed by that material. And on the opposite side, one film will be kept. Okay, one film will be placed, and on that film, that all waves, the pattern will be collected. Okay, that pattern will be collected on that film, and after some time this film is developed, and you will get a developed film, and that developed film is termed as a radiograph. Okay, and in depending or by doing the observation or analysis of these films, you can detect the location of the defect, its shape and size of the defect, depending on the pattern obtained. Suppose in this case, here one you can say that blowhole is present. Okay, when blowhole is present here, then due to this blowhole, what will happen? Absorption of the waves will be very less. Due to that, at that particular area, one dark spot will be obtained on the developed film. Okay, the location where the any kind of defect is there, at that defect area absorption of the wavelengths, or you can say that absorption of these rays will be in very small amount. Due to that you will get a dark spot or a blind spot, and that blind spot will be of the same shape and size similar or equal to the defect present in that test specimen. In this way, by analyzing this test specimen, you can easily detect the kind of this means nature of that defect, its shape and size, with help of this radiography technique. So this is the general principle. Okay, this is the general principle of the radiography technique. Now, this in this radiography technique, you can use X-rays or gamma rays. Okay, you can also use the neurons also. Nowadays the new technique of radiography is developed, that is the neuron radiography is also developed, but that part is not in your syllabus. There are just two types are in your syllabus. The first is X-ray radiography, and second is the gamma ray radiography. Now, how these names are, on which basis these names are given? Depending on the source used. Depending on the source used. Here in X-ray radiography, you are using X-rays. Okay, X-rays as a source to perform the radiography, that will be termed as X-ray radiography. And when gamma rays are used to perform this testing, that will be termed as gamma ray radiography. Okay, that will be termed as gamma ray radiography. Process will be same for both types. You can draw the same diagram. Okay, same diagram can be drawn for both types. If in examination they have asked you the separate X-ray radiography, you can draw this same diagram. Just eliminate this gamma ray name. Just you have to write the X-rays. These are X-rays, and this source will be X-ray tube. Okay, X-ray tube. Then for gamma rays, here for obtaining the gamma rays, what you are going to use? For obtaining the gamma rays, you are going to use the radioactive materials like radium. Whenever gamma rays method will be asked, then here your source will be either a radium, or you can go for the cobalt also, cobalt 60, cobalt 60, or you can go for radium. And there are different isotopes. These are just radioactive materials. They will provide you the radiations or the waves of very shorter wavelength. Okay, and then when X-ray radiography is there, here X-ray tube will be the source. These will be X-rays, and remaining part will be same. Just when you are using the X-rays, the final film obtained will be termed as exograph. Okay, these changes you have to make. Okay, whenever X-ray radiography is there, here X-ray tube, then these rays will be X-rays, the specimen and film will remain same, and at the end this developed film, instead of radiograph, it will be termed as exograph. Okay, EXO dash graph, exograph will be, it will be known as a exograph, final film obtained. And when you are using the gamma rays, here your source will be either radium, or you can write in short radioactive materials like radium or cobalt 60. Then these rays will be gamma rays. Then remaining part will remain same, and this film will be termed as the radiograph. Okay, the radiograph. When only gamma rays are used, then this film will be termed as a radiograph. Okay, when you are mentioning X-rays only, then this name you have to change, and that will be termed as exograph. And when gamma rays are used, you can write it as a radiograph. Radio means it will radioactive material. Graph will remain same. Whenever radioactive materials is there, means it is gamma rays or gamma ray radiography will be there. And whenever X-ray radiography is used, just instead of this radio you have to write here exo. That will be termed as exograph. Okay, so this is the difference, and remaining concept or remaining all procedure will remain same. Now, For just your better understanding purpose, some diagrams are there. These two diagrams are available in the VD Code Gears book. From that book only I have collected these diagrams. This is the arrangement for the X-ray radiography, and this is the arrangement for gamma radiography. Or if you are finding these two diagrams difficult, then you can write this same diagram. You can write this same diagram for both types. Just you have to make the necessary changes. For X-ray radiography, just you have to write here X-ray tube, X-rays, then specimen film will remain as it is, and instead of this radiograph you have to write the exograph. And for gamma rays, this source will be radium or cobalt 60, then gamma rays, and the remaining part will remain as it is. It is known as the radiograph only, film obtained. Okay. These are some diagrams here. What additional part is there? They have made this. Why it is looking so much complicated? Because this is, they have shown the source. Okay, how these X-rays are manufactured, that they have shown it here. Okay, how these X-rays are generated from these electrons. High electrons, we are getting electrons, and that electrons will allow from this cathode filament, electrons will get eliminated, and from these electrons will fall on this anode. Okay, and from this anode they will get direction, and they will allow to fall. This is the test specimen. Okay, this is particular test for welded joints. Okay, these are the X-rays, and they will fall on this X-ray. Sorry, this is the test specimen or your welded joint. And this is the you can say that this is one film or cassette. It will record it, and one lead backing is provided so that these X-rays will not get means they will not travel the other area from the other than that setup or arrangement. It may get hazardous to the human beings. That's why this lead shield is used here. Lead shield. Okay, to avoid the contact of these X-rays with the human beings. Okay, they may create very big hazards if they come directly in contact with the human skins or human body. It will create a hazard. That's why it should be avoided by giving the lead shield. Okay, so arrangement is same. If you are finding it too complicated, just you can draw these diagrams for both. Just make the necessary changes. Okay, so same concept is there. And after that, this is one extra diagram you can add here. This is very simple diagram. Now, what what changes are there? This is the means for that radiography. This is the big difference between gamma ray radiography and X-ray radiography. What is the difference here? In the X-ray radiography, you can inspect only one component at the same time, and when you are using the gamma ray radiography, you can inspect a number of components. These are components only. Okay, here you can put this source at the center. This is the cobalt 60, and on the circular arrangement you can put the test specimen, and this is the film. Okay, all these are the films. This is the test specimen. These are test specimen. This is the film, and from this cobalt we will get the gamma rays. They will penetrate this test specimen, and on this film, for each test specimen you will get the pattern, and the film is developed, and you can detect the defects. Okay, so in this way this gamma ray radiography can be used to do the inspection of number of components at the same time, while in the X-ray radiography you can inspect only a single component. Okay, so this is the diagram for this gamma ray radiography. In this way, you have to explain the principle, then its procedure and how the films are obtained. Then you can explain this. At the same time, you can inspect the more than one components in the gamma ray radiography. And the more after this, this is the very important part or aspect of this. Here, this is the differentiating points. These are the some differentiating points. Lots of time this question is asked in your theory examination. Lots of times they have asked this, or sometimes they may ask you in the objective questions also. In the gate examination they have asked this question. Lots of times I think they have asked this question. I will find whether that question is with me or not. Okay, this question, one objective question I'm having with me from that book only. I will read it for you. This question is asked in GATE 2012 examination in a radiography technique. Okay, I will read this question. This question was asked in GATE 2012. A radiography technique of detecting defects is based on the principle of, okay, on which principle this radiography technique of detecting the defect is based. Okay, four options they have provided here. The first option is you can say that first option is diffraction, then point second option or B option B is a reflection, option C is interference, and option D is absorption. Okay, can you provide me answer for this question? You can put the answer in chat box. I will repeat the question. A radiography technique of detecting defect is based on the principle of option A diffraction, option B reflection, option C interference, and option D absorption. Please put your answers in the chat box. This question is asked in GATE 2012. Okay, means which principle is used in this radiography technique? Diffraction principle, reflection, interference principle, or absorption principle? Very simple question. This is based on the principle only. I have also explained that word here. Yes, the answer is, I'll wait for few more answer. Few students have given answers like absorption, reflection. Yes. Okay. Okay. Correct answer for this is the absorption. Okay. Concept used is here absorption. Okay. In this I have explained that during this principle, the how we are going to detect this defect. Whenever defect is there, okay, these waves will are penetrating this component. Waves are penetrating this components, and where defect is present at that particular spot, absorption of that wavelength will be very less. Depending on that only, we are getting the dark spot or blind spot, and in the remaining areas absorption will be more, and depending on that absorption we will get the different kind of the patterns on that film. So the concept used or principle used in the radiography is the absorption. Okay, depending on the absorption only we will get the different kind of the pattern here. Okay, so answer correct answer for this question is absorption. Okay, then I will move towards this today's lecture's last point, that is the comparison between X-ray radiography and gamma ray radiography. Few points I have collected. The first question, many lots of times they are asking you this comparison questions only for 4 or 5 marks. Minimum you have to write 5 points. Okay, for each correct point means you have to write two correct points. Okay, correct point for X-ray radiography and gamma ray. If 2 points are correct, then you will get this 1 mark. Okay, okay, means description for this and this is correct, then only you will get the 1 mark like this. So okay, minimum you have to write 4 or 5 points. Then what are the differentiating points? I will explain that differentiating points. X-rays are having longer wavelengths. Okay, X-rays are having longer wavelengths and gamma rays are having shorter wavelengths. If you compare X-rays and gamma rays wavelength is shorter. And whenever wavelength is shorter, its penetration power is more. Okay, you can make 2 points from this single point only. That will be also very good. Means X-rays are having longer wavelength, then gamma rays are having shorter wavelength. And you can write in the second point that X-rays are having less penetration power as compared to gamma rays, and these gamma rays will be having more penetration power as compared to X-rays. Okay, then what will happen due to this penetration power? Only because of this penetration power, a large sized components, as X-rays are having less penetration power, please read the third point. Large sized components and non-uniform components cannot be inspected with help of this X-ray radiography because its wavelength is longer and it results in less penetration power. Due to that, large sized components and non-uniform components cannot be inspected. But here, as wavelength is shorter, its penetration power is more, then easily you can inspect large sized components, and non-uniform components also can be inspected in gamma rays. Okay, then a scattering of X-rays, in the scattering means loss of that rays from that source. Okay, that scattering is also more in the X-ray radiography, and scattering of the gamma rays is very less. Okay, now the scattering, due to the penetration power, large sized components can be uh, inspected with the help of these gamma rays, and as scattering is less, non-uniform components are inspected. They may ask you one question: what is the reason behind it? Means large sized components and non-uniform components cannot be inspected by X-ray radiography. Then you have to write, for this large sized components, you have to write its wavelength is longer, due to that its penetration power is less. And for non-uniform components, its scattering of X-rays is more, that you have to mention here. Okay, so after this, the next point is X-ray techniques. Already this I have explained to you, that is, in the X-ray techniques, at the one time you can inspect only one component, inspect or examine only one component. But in gamma rays you can do the inspection or examination of more than one component. Okay, more than one components can be inspected by using this technique. Okay, more than one components you can inspect that. Okay, and then next is whichever equipments we are using in the X-ray radiography, that equipments are larger in size, and that instruments are non-portable. Hence, this method is less convenient. Whichever equipment we are using for gamma ray radiography, that equipments are smaller in size, and sometimes portable instruments are also available. Hence, this method is very convenient. Okay, gamma ray radiography is very convenient method. And then, so all these 4 or 5 points, so first 5 points, you can say that these are advantages for gamma ray radiography and disadvantages for X-ray radiography. Okay, these are first 5 points, these are disadvantages for X-ray radiography and advantages for gamma ray radiography. And last 2 points, these are advantages for X-ray radiography and disadvantages for gamma ray radiography. Okay, if you can write the same points in the, if they have asked you a theoretical question, you can write these first 5 points from X-ray radiography as disadvantages, and these last 2 points as advantages. And here these first 5 points will be advantages and last 2 points will be disadvantages. Okay, that I will explain here. X-ray technique is very fast method. Within few seconds or minutes you will get the result, or that final film will be available. But in case of gamma ray technique, it is little bit slow, and it requires some few hours time to get the results. Okay, it is very fast and requires very less exposure time. It is little slow and requires exposure time of few hours. Okay, and these X-ray method, X-ray radiography will provide you better results when you are doing the inspection of a component having lesser thickness than the 50 mm. This will provide you better result. And gamma rays will provide you, means comparatively these results will be not better, or it will provide you better results if and only if component size is more than 50 thickness, or thickness of the component is more than 50 millimeter. Okay, so these are, you can write these two in the advantages of X-ray radiography. Last 2 points as advantages, and first 5 points will be disadvantages. And in this gamma ray radiography, these 5 points will be advantages and these 2 points will be disadvantages. Okay, if you are having any query, you can put that in the chat box. Okay, if you are not having any queries, I will explain some limitations. Now is some common limitations are there in X-ray radiography and gamma ray radiography. What are the limitations? Limitations are related to only related to the safety precautions. Means there is a possibility of the electric shock in case of the X-ray machines, and in case of the gamma ray radiography, due to the radiations, there is possibility of the human injuries, or radiation injuries may be there. To avoid the X-ray machine shocks in the X-ray radiography, you have to take the proper care, and in the gamma ray radiography, to avoid the radiation injuries, you have to take the proper safety precautions. Okay, and these limitations you can write for both processes, or already few advantages and disadvantages I have explained. These disadvantages also you can add. Then after this, the last point is related to the applications. Sorry. Now last point is the application. Now these X-ray radiographies and gamma ray radiography can be used for detecting the defects, like you can say that cracks, some blowholes, suppose some porosity is there, suppose some inclusions are there of different kind of the materials. In it may be some casted component, welded component. For that, you can use this X-ray radiography or gamma ray radiography. Okay, you can use this for this. This is these are the applications. If you are having any query related to, in this way, we have completed today ultrasonic inspection along with its two types, that is pulse echo technique and a transmission method. And also we have finished the radiography with the its principle and its two types, X-ray radiography and gamma ray radiography, along with their test procedure, advantages, disadvantages, some comparison points, and also along with their applications. If you are having any query, you can put that in the chat box. Otherwise, I will conclude this session. We can okay. Before concluding, I will tell you related to that neutron radiography, which I have told you at the start that that part is not in your syllabus, but neutron radiography is there. Their source used is the neutron. Neutron waves we are using as the source, and that where that technique is used, it is used to find the defects in the it may be a metallic component or non-metallic component, but where it is used, where we are using the assemblies. Suppose you have assembled one part, then now you want to inspect whether that part is assembled properly or not. Okay, after doing the assembly or after getting a finished product with having various components, to check that component, we are going to use that neutron radiography. Okay, neutron radiography means you can say that some nuclear particles you are using there, some nuclear particles or nuclear waves we are using there to allow to pass through that assembled component, and some pattern is recorded, and depending on that pattern only, we are generating some neutron radiographs or neutron films, and that analysis is done. That is termed as the neutron radiography. Okay, This is very rarely used, and it is also utilized for detecting. Suppose you have made some composite materials or some different powder from using the different powders, you have manufactured one component. Then to do the analysis whether there is any kind of the defect in that composite material, or any kind of defect is there in suppose you have used various powders, and whether there is any defect in that combined material. To detect that defect, you can use that neutron radiography. Okay, so that is the neutron radiography. Just try to remember that concept. They may this is not going to, they will not ask these questions in your theory examination, but in competitive examination these questions may be asked. They may put the questions like this: to do the inspection of assembled components, with which method is more suitable? And options will be X-ray radiography, gamma ray radiography, and neutron radiography, and any other four options. Then correct answer will be neutron radiography. Okay, and this neutron radiography is also used for doing inspection of the some explosive devices. Okay, some explosive devices are there, like your detonators also. Okay, detonators or grenades are there. After doing the assembly, these are inspected whether any kind of defect is present inside that component or assembled product. At that time neutron radiography is used. Okay, okay, I think this much is sufficient for understanding this. Now, I will conclude this today's session. Thank you for attending this session. In the next lecture, we will discuss the one remaining method from this non-destructive testing, that is ED current testing, and we will start the destructive testing methods. Okay. In today's lecture, we have completed ultrasonic inspection and radiography along with its different types and its principle, then its advantages, disadvantages, and applications. Okay. Now I will stop here. Thank you. Thank you for attending the session.